Hello, my name is Brandon Denton. In this video I'll be demonstrating how to use my file transfer service named PicSwap, which I have developed as part of a final project for the Introduction to Computer Security course at the University of Tennessee. I've also briefly described how the PicSwap client handles files the user wants to send. The main goal of this project was to create a file sharing service that encrypts files that users want to send in a secure fashion. After researching how Snapchat manages encryption keys for its service, I found some pretty disturbing things. Namely, Snapchat doesn't manage its key well at all. I mention key as singular because Snapchat only uses a single 16-byte key to encrypt every single file that Snapchat clients send. Even more disheartening is the fact that this 16-byte key is hidden in plain text within the source of the client. Thus, anyone with a Snapchat client can decompile the application and know what that key is. This has been parroted across multiple programming forums and other locations, and has essentially negated the entire purpose of the client encrypting any files sent. I kept these security risks and implementation mistakes in mind when I developed the PicSwap front end. Let's take a look at how the PicSwap client works. You can follow along and even test it yourself with files found at my GitHub repository. You can find the link down in the description of this video. We'll start by looking at the client itself, PicSwap.py. This is the script that users will run whenever they want to use the PicSwap service. The client first checks to see if it has a directory for itself, namely PicSwap_data. If this directory is not present, one of two calling functions within the file clienthelper.py will create PicSwap.py on the user's machine. One of these functions is for Windows machines, and the other is for Linux machines. Once the client has ensured that its file structure is set up, it will then attempt to connect with the PicSwap server, which is listening for requests to send files. Once again, this server connection is abstracted away from PicSwap.py into the file clienthelper.py. If the connection succeeds, the menu screen appears, and the client asks the user what file the user would like to send. From this point forward, PicSwap.py uses two functions within the module clienthelper.py, namely generate key and send. We'll examine those in more detail because they're more involved than the other functions within PicSwap.py's helper modules that we've seen so far, and they also contain the primary functionality I wanted to demonstrate. Before the PicSwap client queries the user for files, it first generates an AES key of 32 bytes, composed of pseudo-random ASCII characters. This way the client will produce a different AES key each time it is run. Now clienthelper's send function will use that AES key to encrypt a copy of a file a user would like to send, and then send it through the now open socket leading to the server. The encrypted copy of the desired file will have the original file size and the initialization vector used during encryption as its header. The ciphertext from the original file is written to the encrypted copy in 1024-byte chunks. Once the encrypted copy is made, it is sent along the socket to the server. The client continually queries the user for files they would like to send until the string none is typed. They are then asked if they would like to continue sending files. If not, the client will close after 3 seconds. Without further ado, let's demonstrate the process of sending a file via the PicSwap service. First, we'll need to start up the server. It will continually listen for send requests from clients. I've opened up the server's working directory in a file viewer to the right to show that the server both writes AES keys and files that are sent via the sessions socket. Now that the server has begun listening for requests, let's go over to my Windows machine and run the PicSwap.py client. At startup, the client will ask us what file we'd like to send. I already know a name of a file in PicSwap's working directory, so I'm going to choose that one, which is L2P3.c. And once we hit enter, we'll see that the server has both accepted a connection from the client and has written two files from that connection. First, the AES key in a file marked AES key, and the encrypted content of the desired file from the client named 0_. This file can later be decrypted with the key inside the file AES key using the script PicSwapRead.py included in my GitHub repository, which decrypts files in a similar method to how they were encrypted in the PicSwap client. The file with the encrypted content from the user already has the initialization vector as its header, so that can just be read by PicSwap Read and used in conjunction with the AES key in the separate file to decrypt the file sent to the server. Thank you for watching this demonstration of my project, and have a lovely day.